Assalamualaikum and hello IB to everyone who's watching this video. I am Shana binti Aisan, a final year student of Science Physics, University of Malaya. As you can see from the title, Small Angle X-ray Scattering Measurement on Bladder Cancer Associated to Cisplatin Resistance. This is actually my final year project title, and today I would like to share with you guys about it. Before I get into it, I would like to ask you guys one question. What would you feel if you know that one of your family member or even yourself is diagnosed with cancer? You must be feeling devastated or even hopeless. It is already terrifying to even think about the word cancer itself, because we all know that this disease has a very high risk of mortality. In the effort of finding the treatment, the experts might serve as many options, but we need to keep in mind that every human body responds differently towards any kind of treatment. The question is, how can we know what kind of treatment will work best on the patient? In the present time, it has been quite a number of diagnostic methods for bladder cancer, such as cystoscopy, biopsy, or even imaging tests like CT scan and MRI. This procedure being such a glorious method in detecting bladder abnormalities, human error might still happen, and the vary in the professional experiences among clinicians has the potential to affect the patient's diagnosis. This number of cases is majorly caused by the treatment rejection. Cisplatin-resistant disease causes majority of the patients who initially have positive result from the cisplatin-based chemotherapy to relapse. In this era of advancement, we focus on the development of technology which can help us to improve our daily life. Hence, in this project, SAX machine with synchrotron radiation source has been used to observe the bladder cancer with cisplatin resistant to analyze the differences occur in the tissue structure. The determination of this project is to characterize bladder tissue sample by observing the possible differences in the SAX diffraction imaging between samples provided. Parameters of the axial peak features, including disc spacing, FWHM, peak area, and even scattering intensity is very important in obtaining SAX imaging. Profile scattering vector Q analysis between two triglyceride peaks, which is at Q equals to 1.5 and 3 per nanometer. Shown in the figures, we can see that there are differences and shifting of triglyceride and collagen peaks. However, only sample A and B show the collagen peaks, while sample C only show triglyceride peaks. Sample A shows a significantly high intensity of triglyceride peak at Q approximately 1.5 per nanometer compared to the other samples, while triglyceride peak at Q approximate to 3 per nanometer can be seen as the lowest in scattering profile of sample B. According to Park's law, it is proven that the intensity of the peak increases along the surface area of the scatters per unit volume and contrast of electron density. Is disc spacing. Axial disc spacing represents the spatial spacing between gap overlap part of collagen molecules. Hence, the bigger the value of disc spacing, the bigger the distance between two atomic layers. However, the specific values of disc spacing of every main observed peaks are not obtained, as the value of n used varies from 1 to 10 using the Dirac-Bragg's law, which is D equals to 2 pi n over Q. Moving on to the next parameters, both FWHM and axial peak area were determined by fitting the converged peaks by using Origin Pro 2018 software. Value of FWHM at Q approximately 1.5 per nanometer is 0.08 plus minus 0.06 per nanometer, while at Q equals to 3 per nanometer, the value of FWHM is 0.09 plus minus 0.03 per nanometer. On the other hand, the values for peak area are about 2.1 times 10 to the power of negative 3 and 7.6 times 10 to the power of negative 5 for Q 1.5 per nanometer and 3.0 per nanometer respectively. In conclusion, I hope this work can be continued in the future with more tissue samples to obtain more accurate data in considering small angle X-ray scattering machine as the next advancement in pathological field. That's all from me. Thank you for spending your time and have a good day.